here's the video for Module 3. So we're just going to be solving equations and inequalities, quick review of that. In order to solve an equation, you have to remember that you use what's called inverse operations. So I know this is simple, but get it in your head. The opposite, or the inverse of adding, is subtracting. So therefore, the opposite of subtracting is adding. They go together. Same with multiplying and dividing. The opposite of multiplying is dividing. So that means the opposite of dividing is going to be multiplying. If you get those processes in your head that they're opposites or inverses, you can solve any equation we're going to throw at you this year, whether there's a square root or a cube or anything like that. All right, number one, let's start with some regular simplifying. When I teach Algebra 1, I call this fraction here, I call it the fraction bubble. And I want to deal with everything outside of the fraction bubble before I can deal with the -3 over 2. I want to get x by itself. So the thing that's outside the fraction bubble right now is the 7. It's being added, so I have to subtract it from both sides. That'll give me x minus 3 all over 2, and 23 minus 7 is 16. Now, I can't touch the x until the fraction is gone. I don't like fractions. The 2 here is being divided. So we said the opposite of dividing was multiplying. So I'm going to multiply both sides by 2. Now all that does on the left is it cancels the denominator. It does not change the numerator. The numerator is still x minus 3. And we'll set that equal to 32. So now all you have to do is add 3 to both sides, and you'll get the final answer that x equals 35. B is going to be very similar. I still have a little fraction bubble right here. Can't do anything with it until I subtract the 6. Right, so I have -5 over 2, x equals -5. Now again, I have a denominator and a fraction. So to move that denominator, I'm going to multiply both sides by 2, make that -5x equals -10. And to move the -5, it's multiplying, so I have to divide it away. A negative divided by a negative is a positive 2. Now let's look at example 2 here. All right, in order to solve these, I'm going to have to get rid of the parentheses first. So what I'm going to do is I'm going to distribute the -2. -2 times x is -2x, and then positive 14 equals 12. Now that the parentheses are gone, it's really easy to go ahead and subtract 14 from both sides. -2x equals -2, and then go ahead and divide by -2. Negative divided by a negative is a positive 1. All right, look at problem B. I have to distribute first. Now, I only distribute the 4 to what's inside the parentheses, not the -2. So 4x plus 4, and then I still have to write that -2 down because I didn't distribute to it. What I do next is I combine like terms. So 4x plus 2 equals -6. And now I go ahead and can subtract 2 from both sides and get 4x equals -8, and then divide by 4. A negative divided by a positive is a negative. All right, moving right along to example 3. Solve for x. Now notice here that there is an x on both sides of the equal sign. There's also a constant on both sides. It does not matter which you move first, what x or what constant. Just pick something and move it. I'm going to start with the -7x. I'm going to add it. Now the only reason I'm doing that is because that gets rid of the negative for me, and we don't like having negatives around. So I'm going to add that away. It goes away on the right, but now on the left-hand side I have 16x minus 6 equals 10. Well, now we only have x on one side, so I'm going to just finish solving here by adding a 6 to both sides. I'll get 16x equals 16, and then I can divide by 16. That'll give me x equals 1. Right. Another x on both sides. Now I have a fraction. When I look at my fraction bubble, there's actually nothing going on the left other than the fraction. So to get rid of the denominator, I'm going to multiply both sides by 9. Again, that leaves the numerator alone. It doesn't change, but the right-hand side is now 90x. I have x's on both sides. I'm going to move the left x because that way I still have something on both sides of the equal sign. So I have 1 equals 45x, and all I have to do is divide by 45. Now I can leave that fraction as it is to be 1 over 45 equals x. Unless it says to round to a decimal, go ahead and just leave things as an exact fraction. All right, flip to the back, example 4. Let's put everything together, distributing x on both sides. This problem looks a little bit yucky, but it's really not going to be that bad. Start by distributing. Okay. I'm going to distribute everything in a different color so we can see. Okay, so the first one, 7x minus 14. Then I distribute the negative 3 to be negative 3x minus 9. Set that equal to 5x minus 15 and plus x on the end. All right, no parentheses left. So all you have to do is now combine like terms. I'm going to change the pen color here. Here I have x's on both sides. 7 and minus 3 is 4x. Negative 14 and negative 9 is negative 23. On the right-hand side, I have 5x and x, which is 6x minus 15. Now this looks like what we did back in example 3. All I have to do is get the x's together, so I'm going to subtract 4x here. And negative 23 equals 2x minus 15. And then add the 15 to both sides. Gives me negative 8 equals 2x, and divide by 2. So that tells me negative 4 is the value for x. Next one, B. Let's go ahead and distribute the 5. Oh, yeah, we'll do that. We're in our fraction bubble here. I don't want to forget about fraction bubble. So I'm going to distribute the 5. So I'll have 10x minus 5 over 3, and I still have my negative 3 on the outside. Now, the reason I still have the negative 3 is I have to move that first. I didn't distribute to it. It wasn't in the fraction, but I can now move the 3 to both sides. Now, when I move the 3 to both sides, I end up with 10x minus 5 all over 3 equals x plus 3. Those aren't like terms, so I have to leave the plus sign. In order to move the denominator from the left-hand side, I multiply both sides by 3. Now, when I multiply the right side by 3, I technically multiply every term by 3. Not just the x, not just the 3, but both of them. So I end up with 10x minus 5 equals 3x plus 9. All right, now I just move the x's and I move the constants. I'm going to move the 3x first. So it gives me 7x minus 5 equals 9. And then I'll add 5 to both sides. 7x will equal 14, and when I divide by 7, I get the answer of x equals 2. All right, let's look at example 5 here, challenge problem. Kind of combines a couple of different modules here. On the left-hand side, I need to get rid of the parentheses. So I'm going to start by double distributing. X squared minus 7x plus 1x minus 7. Now, I'm going to set that equal to the right-hand side. You should see that these inner x's are going to combine together. So I'm going to have x squared minus 6x minus 7 equals the same right-hand side. Now, I want to put all the terms together. I have an x squared on both sides. I'm going to deal with that first. If I subtract x squared, notice that it actually goes away from both sides, which is good because we haven't solved anything else with an x squared yet. So really, you just have negative 6x minus 7 equals 2x minus 3. And you can go ahead and just finish solving that like we have been. So I'm going to move the 6x, so I get rid of the negative. Negative 7 equals 8x minus 3. Add the 3. So I have negative 4 equals 8x. And when I divide by 8, I get negative 4 over 8, which is negative 1/2, is my value of x. All right. Last, it should, yeah, it does say example 6 on here. I think on your paper it says example 7, but that's okay. We're talking about inequalities, just 3 of them to finish here. Solving inequalities is exactly the same process as solving an equation. However, you must remember that if you multiply or divide by a negative value, you must flip your inequality sign. So if you multiply by a negative or divide by a negative, you have to make sure to flip the inequality, and I know we will see that somewhere here in a couple minutes. Let's distribute the 3 to start. I don't want the parentheses. 3 times 6b is 18b minus 3. We keep the inequality symbol the same. Don't turn it into an equal sign. Leave it the same. Now I want to get all the b's together, so I'm going to add 3b to both sides. So that'll give me 21b minus 3 is greater than 18. And then I'll go ahead and add 3. So 21b is greater than 21. And when I divide by 21, I get the solution that b is greater than 1. Now that's the value. Now I want to know which value of b is actually in this solution set. Now think about a number line. If I had 1 here, greater than 1, remember when we made these solutions a long time ago, we would put an open dot because it was greater than, and we want all the numbers bigger than 1. So I want to see which numbers of those 4 would be greater than 1. Well, it's not 0. 0 is less than 1. 1 is equal to 1, but it's not greater than. So 6 and 9 are the only values that would be in that solution set. For b, start again with distributing. Of negative 5 plus 20a is greater than or equal to negative 5. So I'm going to start by adding 5 to both sides. 20a greater than or equal to 0. And then I have to divide by 20. Well, 0 divided by anything is 0. So I have all the values of a that are greater than or equal to 0 are my solution. So just like we did, if I was at 0 here, my answer includes 0, could be equal to 0 or greater than 0. So that would include 0 on here. Negative 8 is less, 2, and 7. All right, finally, part C. I have a fraction, so I need to think about my fraction bubble. So I'm going to subtract 5 from both sides to start. I'll have 2x plus 2 over negative 3 is less than or equal to 12x minus 7. Now I want to get rid of the denominator. So to do that, I'm going to multiply everything by negative 3. Multiply every term. But when I'm multiplying by a negative, there should be an alarm going off in your head right now. I multiplied by a negative. That means when I write my next step here, 2x plus 2, this sign needs to flip. Now it's greater than or equal to. 12x times negative 3 is negative 36x plus 21. The sign is flipped, so I'm good to go on. I'm going to move the 36x, which will make it 38x plus 2, greater than or equal to 21. Go ahead and subtract 2 from both sides. Get 38x is greater than or equal to 19, and I'm going to divide by 38. That gives me a solution that x is greater than or equal to 1/2. So when I look at all my numbers greater than or equal to 1/2, negative 2 is not bigger, 0 is not bigger, 1/2 is equal to 1/2, and 8 is greater. All right, hopefully that refreshes your memory on equations and inequalities. If you need some practice, there is practice on the next page.